Hi, everybody. Can you guys hear me all right? Excellent. Are you guys having a good morning so far? Woo! All right. So, hi. My name is Kenneth Reitz. If you'd like to follow me on Twitter, my handle is @KennethReitz. And I work for a company called Heroku. They're a sponsor at the conference here, and they sent me out to come speak. If you're interested in solving interesting problems, we're hiring. We're a really great web application platform for deploying all kinds of applications, but specifically Python. But enough about that. So I, in general, try to do as much open source in my life as possible. I really, really love open source. And if you know who I am, it's probably from the open source work that I've done. Some of the projects that I've written are Requests, which is HTTP for humans, which we'll cover in a little bit more depth in a moment. Thank you very much. HTTP bin, which kind of evolved out of the Request project. So I was like writing unit tests for Requests, and I needed to have some kind of a service that allowed me to just kind of inspect and see what was actually being sent to the server. So this is a nice little mirror, essentially, that you can run locally or use a hosted version, and you can send it different, it'll give you different scenarios if you'd like. So you can tell it to give you a certain status code, and it'll respond with that, or challenge a certain type of authentication. And if you start messing around with a lot of HTTP clients, it can be kind of frustrating, because like, you see like the connection header there and the user agents and like the content type, all these different client libraries will all do different things. So this is really useful for trying to figure out what's actually going on. Some other things I've written there is Legit, which is a Git workflow library for humans. Essentially, there's GitHub for Mac, which is this really great command line, or not command line, it's a GUI interface for Git, but it actually introduces some new workflows into the way you use Git. So if you switch branches, it will automatically like stash and unstash changes that are pending, which is really great if you're working on a lot of feature branches. So I don't really like using the GUI though, so I kind of made a version of that works on the command line. It's called Legit, and you can check that out if you're into Git. Some other things, Envoy, TabLib, Clint. AutoEnv, which is kind of cool. I use this to automatically activate virtual envs when I'm working in a bunch of different projects. So it's a little bit evil. So it overrides CD, for example, in your shell. But you know, it's a logical choice. I think that's a personal decision. Essentially, like if you add a .env file to any of your projects, it'll execute that script once it asks you. You have to authorize it. But it'll execute it when you cd in. So you can automatically activate a virtual env or set configuration variables or stuff like that. It's pretty cool. And then there's OS X GCC installer, which allows you to install Xcode on your Mac without using, GCC on your Mac without using Xcode. And that makes Apple's lawyers very tense. But they're okay with it, though. So as I've been like working with all these open source projects, I'm really kind of like starting to adopt this philosophy of like open sourcing everything in my life. Even if I'm writing a piece of code that isn't ever going to see the light of day, I think it's really beneficial to treat it as if it's going to be an open source project. So say I'm working on a company project that's going to be internal only. If you just kind of pretend that it's an open source project, a lot of really great practices kind of naturally come to light from that. So you have different components that become really concise and decoupled from one another. Oftentimes you have really big code bases that when they're internal and they're like undocumented and they'll like start calling each other directly and they're very tightly coupled. And if you just kind of like treat everything as if it's an open source project, a lot of these things just kind of magically disappear because an open source project is only as valuable as the documentation that you provide. Because if it didn't have any documentation, no one would be using it. And I think the same applies for internal code. I mean, I'm sure everyone here who has ever worked with internal, you know, like who here hasn't worked with internal code that hasn't been documented? Like, it's the most frustrating thing in the world. Well, I'm very jealous of you. Yeah, and like a lot of really great practices kind of emerge from this as well. So, for example, if you're going to have an open source version of an application that you're deploying into production, you wouldn't be storing like database credentials in your repository because they're going to be seen by the world. That's not something you should do for your internal projects either. So all these really great practices kind of come to light. And the beauty of this is that the code can be released at any time if you ever do choose to open source it. So that's kind of cool. So people love Python for a lot of different reasons. And I think it really comes down to philosophy. We all kind of like share this really dark past of why we love Python, right? So anyone can shout out any other languages I missed here, but like we all come from like Perl or Java, PHP, Cold Fusion, all these languages and these ecosystems that are very frustrating and are kind of like missing the point. And Python kind of goes a step further to try to solve this, and that's the big reason why a lot of people use Python and why it's so valuable. And this is kind of represented by this thing called the Z of Python, which is known as pep20. So in any Python interpreter that you have, if you go to it and you type import this, you're going to see a list of 19 things that are the essentially very concise statements that try to represent the ethos of the Python community. And we're going to go over a couple of those. So the most important one, which everyone's probably the most familiar with, is beautiful is better than ugly. Python really tries to spend a lot of time optimizing for readability of code, because you spend a lot more time reading code than writing it. And there's like no brackets or braces, things like that, that are very prominent in other languages because it's visually distracting and not necessary. Explicit is better than implicit. So if you're working with a lot of languages like Ruby, you'll have a lot of like variables that just are kind of like stuck in random places, and things change implicitly. So you'll import a certain module, and then all these other things change. Like you'll have methods added to core data values, data types, and things like that are unobvious, and it can cause a whole lot of confusion. So if you're working with Python, all those things are like very explicit. So if anything's changing, typically it's very obvious when you look at the code. Simple is better than complex, and complex is better than complicated. Those ones are kind of obvious. And if the implementation is hard to explain, it's a bad idea. And I think we should add this to the PEP, except PyPy, because it's extremely hard to understand, but it's an amazing project. And it is the most important one that we're going to touch on most today, which is there should be one, and preferably only one, obvious way to do it. I think this is kind of the most important thing in Python that kind of separates us from a lot of other languages. If you look at like Perl and in Ruby, they all kind of pride themselves on the expressiveness of the language that allows you to do things in as many ways as possible. And in Python, we try to really make it so there's one obvious way to do something. And I think that that's really important, and that kind of gives us that pragmatic approach to writing code. So like if you're working on a team, you don't necessarily have to disagree on which expression style you're using when you're pushing out a piece of Python code, because there's obviously one preferable way to do it. So let's say you were working in one of those other languages, and you decided to do Python. Now, you were frustrated with your dark past, and now you want to learn Python. It's going to be awesome. You see all these values. They have it all documented. They have this great PEP system that kind of like expresses what the community is all about. You're real excited. It's going to be a paradise. And I don't think that necessarily holds true. So let's say we know Ruby, and we're going to take a small piece of code here that we wrote in Ruby, and we're going to port it to Python. Because the best way to learn a language is to take a small piece of code that you know, or a library, and then try to port it over to the new language. And so what we're going to do here is just send a simple HTTP request to the GitHub API and get the response. And then we're going to do the same thing in Python and see how it goes. So in Ruby here, it's pretty straightforward. It's very verbose, but it is a very explicit set of instructions that you have to give the interpreter here. So let's go through it. The first thing you do is you import a net HTTP module, which is available in a standard library, and a URI parser. And then you instantiate the URI parser with the URL, the GitHub API/user. And then you create an HTTP connection, and you pass in the parsed host and port from the URI. And then you tell the HTTP connection to use SSL. And then you create a request from the connection with the URI passed in, and you attach your basic authentication to the request, and then you make your request and you get your response. It took a little bit of work, but it was pretty straightforward, and that's, I don't know. I think it's a pretty nice way to go about things at a low level. So if you go and try to do this in Python, you'll kind of notice that you have a lot of questions that start to arise. The first thing you're going to do is try to figure out where Python's net/HTTP module is, and you're going to find that they don't necessarily have one. You have a HTTP lib, HTTP lib2, URLlib, URLib2, URLib3. So many different options, and it's not very clear which one is the de facto to use. So if you like search online for several hours, you'll kind of find the best practice that's recommended by a lot of people is urlib2, and that's kind of like what that's like the latest module that's in the standard library. It's what a lot of people point to in their documentation, and that's kind of like the de facto, just use that. So you're going to try to write this code in urlib2, and several hours later, this is what you're going to come up with. And I think, well, let's go through it and you'll see. So what you do is you import urlib2, and then you have a reference to your URL, and then you have a request object that you instantiate from the URL. Excuse me. Then you have a password manager. Sorry. You create a password manager called an HTTP password manager with a default realm. And then you add your password to it with reference to the URL, the username and password is being passed into the password manager. And then you have your basic authentication handler that you create from the password manager called your auth manager. And then you create a urlib2, you build a urlib2 opener from the auth manager, and then you install the opener, and then you have a handler that you can do to open requests, and then you can print the response from a socket API. What the hell? This is ridiculous. And I actually lied, there's more. So the way the GitHub API works is it actually sends you back a 404 for a protected resource. That way, let's say if you were like looking at someone's repos and you were like going through and trying to guess the names of their private repos, if it was asking for a 401, which is a challenge response, then it would essentially be telling, the GitHub API would essentially be alerting you to what the names of the projects were if you guessed properly. So instead, they just say 404, and you have to send the authentication explicitly. And we explicitly attached it to that request. And, but urlib2 still kind of tries to do the best practice way, not necessarily the pragmatic way, which is only send the authentication when the server asks for it, even though we explicitly passed it in. So to override this behavior, we have to do all this crazy regex overriding stuff to subclass this, and it's just a big pain. And it's actually, the real code example would like go down into the floor here, so I kind of truncated a bit, but it's not very pretty, obviously. So I really think that this is a serious problem. Like if this was me and I was trying to learn Python, and this is my first experience with the language, I would leave and I'd just never come back. Like this language like has all these values that they try to push and that they say that are so valuable to them, and then look at that code. I mean, it's the opposite of anything elegant or beautiful or anything. And there's like obviously not one way to do it because there's all these different modules that answer these problems. It's a very serious issue. So the problem is that it's unclear which module you're supposed to be using in the first place. The prognosis online seems to be that you should be using urlib2, where the docs are really, really bad. And if you actually land on the docs, essentially there's very little directions on how to actually make a request. It'll tell you how to like make a simple GET request, but nothing with authentication and things like that. So if you like search online, you'll find like Void Space has written some really great urlib2 documentation, but it's like not in the standard library docs, so it's not you have to go find it. And even once you do find that documentation, it's the worst API in the world. It's not something that's easy to understand in any way, and it's extremely frustrating. So a lot of people think this isn't really a big deal. Like you just write your little wrapper for your application when you need to, and then you just kind of go on your merry way. But I really think this is a serious problem, because HTTP really is like our universal language today. I think in general, like if you're going to be communicating across programming languages or just across services or companies or anything, HTTP is really where all this happens, right? Like our whole world is run on HTTP at the moment. You know, the whole social media and the whole entire world is like interacting with HTTP every day. So it should really be a first-class citizen in a language, and it should be as simple as a print statement, I believe. So I think the solution to a problem like this is pretty simple. We really need to build elegant tools to perform tasks like these. And I like to call those pragmatic packages. And I think Python really needs a lot more of these. Pragmatic means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. If you go and you look at the urlib2 code base and all of these different handlers and authentication systems and openers, and default realm, password manager realm things. Essentially what they're trying to do is fit every theoretical use case possible. And by doing so, what they're actually doing is taking away from the experience of the 95% of the people that are going to be using it to actually get work done. And that's kind of where that line needs to be drawn. So I like to call these pragmatic packages Python for humans. So let's break down what HTTP actually is at its core. Essentially, it's a small set of methods with consistent parameters. You have head, request, get, push, post, delete, patch, etc. And all of them are fairly straightforward. They all accept headers, URL, parameters, body, or form data. And that's pretty much it. There's like status codes that are also used to respond, and there's different little things that you can do. Like if there's a 301, you're supposed to follow the redirects and such. But like at the core of HTTP, it's a very simple and straightforward protocol. But when you look at urlib2, it's kind of like the opposite of that. It's like this super over-engineered piece of code, and it ignores all the values that all of our values as an ecosystem in Python. The docs are impossible to read. HTTP is really simple, and urlib2 simply isn't. And I really think that can scare people away from Python. So I wrote requests, which is HTTP for humans. And to do the exact same thing that we just showed you in urlib2 and in Ruby, this is all you have to do. You import requests, and you have your URL, and then you have a username and password, and you make a GET request, and you get your response. Yay. Yeah. Achievement unlocked. We have a small set of methods with consistent parameters. We have a get, a post, a push, a put, delete, etc. And they all accept headers, URL, parameters, body, and form data. Woo! Do this with everything. The litmus test is if you have to refer to the documentation every time you use a module, then you need to find or build a new module. And to do so, I think it's really important to try to fit the 90% use case. If you build something like this, it's very simple to use for 90% of the people that are out there. There's going to be like those 10% of people that are going to be complaining that you're not doing things exactly the way that, for their specific use case. And I think it's really important to ignore those people. You can have layered APIs, so you have like a very low-level thing that allows them to kind of get it down and deep into the core if they want. But the top level, like that 90% of the people are going to be using, they should not be concerned with those lower-level parts. And I think that's really extremely important. So the API, I think, is really all that matters when I'm building packages like this. I try to essentially ignore everything else, because I think everything else is really secondary to the actual developer API. And I really mean everything, like features and efficiency, performance, corner cases. All of those things are important, but I think they're all secondary to the API. And I'll show you what I mean. So when I'm writing code like this, the first thing I do is I actually like to write a README before I actually write any code. So if I'm going to write a module, I'll actually sit down and I'll write the README with example usage of how to use this thing before a single line of code is written. And essentially, it allows you to really interact with the problem directly and try to figure out what the best API will be. And then once you do that, then you can go through and actually write all the code to make it necessary for that to happen. And if things are complicated, you can kind of step back and start writing have like a layered API. If like one of those single function calls that's in your README actually has like 1,000 lines of code behind it, you can obviously break things up. But the top level user-facing API is extremely important. So, but when you write modules like this, you can essentially pivot your way into improving all those other things as you go. So at first, request was really far from powerful. It just kind of worked, and it was not very well designed, but the API was like really solid, and it's essentially the same thing as it is today, with some very small changes. So it wasn't very powerful, but it really deeply resonated with a lot of developers, and the features grew over time, and the API was never compromised. So today, request supports cookies, sessions, content iteration, decompression, file uploads, asynchronous I/O, keep alive, connection pooling, callback hooks, proxies, OAuth, etc. It has had 1.4 million downloads from the cheat shop, and a lot of really major companies use it in their day-to-day work, which is pretty awesome. But cool story, bro. Why am I telling you all this stuff, right? I think it's really a testament to the fact that everyone wants better APIs, and we really need them in our day-to-day work. And I think it's worth your time as a developer to build APIs like this, because obviously people find them valuable, and it's worth everybody else's time as a user, because it saves them a lot of effort and energy. And it saves the community as well. So when you're working with Python a lot, I think that there are also a lot of other barriers to entry that aren't necessarily related to APIs. And I'm going to kind of go over what some of those are. I sent out some like surveys to people that teach a lot of Python, and like my personal experiences, and these are kind of the different things that are often big stumbling blocks when you're working with Python. So file and system operations can be a bit clumsy when you're working with Python. Does anyone ever have this problem of like the sys, shutils, os path, io? Like I always have to look up which module one of like the function I'm looking for is in. It's very unclear to me which one is actually used for what. Some other complicated things, there's like the subprocess module is really hard to understand and use. If you look at the API as like this single class that you instantiate with like 13 different arguments with like arbitrary names, essentially it's bumbling up the exact same C API that's powering things. But it like makes it really hard to like use Python for a lot of like Unixy system things because it's very unclear how to use this module. And I think that really blocks a lot of like DevOps people from adopting Python, or people that just use like like Unix style programming of just like piping things out and shelling things around. That's not a first-class citizen in Python. And in other languages, that can be quite simple. So that's something that I think could really use a lot of improvement. All right, let's have a quick show of hands here. Who here uses Python on a Mac? Awesome. Now, who here has installed it from Homebrew? Who has installed it from Think or Mac ports? I'm sorry. Who here has installed it from python.org? Built it from source? What's the other one? Oh, use a system Python that comes with it. All right. So what happened to there being only one obvious way to do it, right? Like there's all these different ways to install Python on your Mac, and no one really knows what the best practice is. A lot of other questions that kind of come to light here is there's like Python 2 versus Python 3. Someone has to decide which one to use. And I think in like the next 2-3 years, it's going to be a lot easier. But at the moment, that's a question that a lot of people have as they're coming in. You don't know where to install Python if you use 32-bit or 64-bit. If you're building Python on your Mac, you have to choose between a Unix build and a framework build, and there's no documentation on what the difference is between those two. But they can have some pretty serious implications later down the road. So these are all important things that I think really need to be documented. And obviously, there should be one preferable way to do it. And that's not the way it is today. So some other things that are kind of frustrating to people. The etree API, people don't necessarily like very much. The LXML library is super, super great. But it can be really difficult to install. Things with C dependencies in general are kind of a very frustrating experience with Python. Some other kind of gotchas these ones are pretty big here. So like, people know to use pip typically instead of easy install, but they don't necessarily know why. If you're using like Python that comes with your Mac, easy install is already available. So a lot of people don't realize that that's actually not a part of Python at all. Like that's like an ecosystem tool. There's no uninstall, obviously, as well. It's kind of confusing to people. A lot of people use distribute instead of setup tools, but again, they don't know why. It's kind of controversial over which one is preferred, and there's a lot of dissonance in that area. And that really causes a lot of confusion for people. So people just kind of skirt away from like packaging in general. And then you see a lot of projects that just kind of avoid it. And I don't know, it hurts the ecosystem, I think. Some other issues that kind of come up are setup tools appears to be built into Python. Broken setup.py files, people like to ship those a lot. So if you try to compile something, like not LXML, that's like an example of something that has these complicated dependencies. A lot of times the setup.py files are just like really messed up, and you have a hard time trying to accomplish what you're trying to do. And another really big one is released packages that people have like marketing for and like documentation, and then like they say to install it, like go to GitHub and clone the repo and run setup.py install. Instead of having it, actually like in the cheese shop. I think that's a really big deterrent in the community as well. Some other issues that kind of come up a lot is the date times issue. Which module do you use? There's date time, calendar, date util. If you just do pip install date util in Python 2.7, when you import it, it will just fail. It's because it's actually the Python 3 version, so you have to be very explicit and specify that you want the 1.5 release. And that causes a lot of problems for people. Time zones, I'm not going to get into that, but I'm sure we've all felt that pain. Apparently the standard lib can generate but not parse ISO 8601 dates, so that's kind of a big deal. Unicode is a big deterrent when you're learning Python. I think it's a fairly simple thing once you understand how it works in Python. And like usually there's like this one resource that you'll find eventually, like after writing Python for 2 years, that will like explain exactly how it works, and then suddenly everything makes sense. But like getting to that piece of documentation is really important, and that's not necessarily an easy thing. Like if you go look on Stack Overflow at like new users of Python and the issues they have, like almost always it's like the mysterious value or decoding error, and it happens constantly. Testing, there's a lot of things that can kind of be, I think, documented in this area. There's a lot of different test runners and ways to write tests. You have, there's like talks, and then there's py.test and nose, and it's not very clear which ones are used for which. A lot of people try to use doc tests for very serious tests. And yeah, so there's a lot of like just dissonance in that area, and it's not very obvious what the best practice is. If you're writing Python on a regular basis, like these things are very obvious. But if it's like something like what you do every day, but if you're a newcomer, like these things aren't written down anywhere, so it's very hard to kind of learn. Installing dependencies. Has anyone had this issue with like the MySQL library? Like, my solution to this problem is to use Postgres, but like it's really hard to install. Like, I never remember what the name of the module is in the first place, and once you do, you have to have like the Unix socket available for it to bind to when you build, depending on what version you're using, and it's super complicated. And like the latest version of the MySQL driver requires like the latest version of distribute, so if you have like an older version, it just fails, and it's terrible. Python imaging library is actually fairly simple to install once you understand, but again, it's like not in their documentation. All you have to do is like have live PNG and JPEG available, and then everything just kind of works. But like when you have the errors that happen, like it doesn't say that. It's just like this big glorb of text that's like completely like Greek to most people. And it's pretty bad. ModWizgy, like if you're using system Python, like Ubuntu, you want to like switch which version of Python you're using, like trying to build a new version against that is like, no one even knows where to start. LXML is a little bit hard to install. I think they actually do a pretty good job. So what they do is when you download a package, or when you try to install this package, if the dependencies that it needs aren't available on the system, it actually gets them itself and then statically compiles itself against them. And that's something I think a lot of projects should probably be doing, because it really makes it a lot easier. But for a while, LXML was like impossible to use if you didn't know what you were doing. So this kind of leads people to using system packaging for their Python packages. So everyone just kind of apt-get installs LXML. And then they like don't know what version of Python they're using or what version of all these libraries. And it's a bad coupling that I think needs to be removed from the ecosystem. So my solution to all of these things is this thing called The Hitchhiker's Guide to Python, which is available at python-guide.org. And of course, it teaches you to never panic and always carry a towel. Hitchhiker's Guide to the Galaxy. And it kind of serves a couple different purposes. It tries to document all of our best practices. If you're a newcomer to Python, and there's all of these like social best practices that everyone knows about, because we all talk about Python to each other on a daily basis. But these things aren't necessarily written down. And like it can be really hard. Like if you're a newcomer to Python, and you're like, it can be really hard to even know like what the cheese shop is. Like you can know that you can pip or easy install something, but like getting one of your own packages up there, like the path to figuring that out without like tapping someone on the shoulder is really, really difficult. So this project kind of tries to be a guide for everything, try to like give a very simple documentation on all of these social things that we all know and use on a daily basis that aren't very obvious. And it also is a reference for seasoned veterans. So say you're a Python developer that's been working in scientific computing for a long time and you want to switch to web development, you're not going to know which frameworks to use. So it'll recommend the best practices there and how to deploy things. And of course, it'll teach you to not panic and always carry a towel. Some of the best practices it'll recommend, for example, is using distribute, pip, and virtual env right out of the box. And it'll be very opinionated, too. So it won't necessarily have documentation on build out or easy install and things like that. It'll just push you right to the best practice. And there'll be explicit installation directions on every operating system. So that'll make it so there's only one way to do it, which is great. It'll instill a resistance to doc test for serious testing, and it'll teach people to use datetime.utc-now to keep them from shooting themselves in the foot down the road. But there's only one rule, and it's that there should be one and preferably only one obvious way to do it. And I think this really fixes a lot of things. It makes Python more accessible, it lowers the barrier to entry to the language, which gets more people involved and makes our community better and changes the culture slowly. And I think it really sets developers on the right path. And it really allows us to practice what we preach. We have all these values that we try to push, and they're really great, and they kind of form everything that we do in the Python community, but there's always work to be done. And I think having a documentation like this that's opinionated, I don't think this necessarily belongs on like python.org. At this time, like python.org isn't in the position to be making opinionated recommendations that like use Django and not something else. So it really allows us to like practice what we preach of having that one obvious way to do it in a non-agnostic way. So the manifesto of the talk is simplify our terrible APIs and document our best practices. Any questions? Awesome. Oh, yes.
So I always thought that it was a bit of an unfortunate choice that the Python standard library plastered all of its packages all over the namespace rather than having like from std import the standard packages and then everything else. But now I'm realizing that actually may be a blessing because it means that there is an opportunity to create something like std or new std or whatever, which would be a collection of decent packages to replace some of the crap that you've been pointing out, validly pointing out from the standard library. And I don't know if you've thought about basically beginning to put together a collection, at least of things that fix some of the worst pain points of the standard library, which you pretty much hit everywhere. And if you do, the only thing that I would like to beg that you add to everything you've said today is that everything has to go in with proper, decent doc strings. And in that regard, I would encourage you to have a look at what the NumPy community has done, because what we've done is we've developed a NumPy docstring standard, which we use. It's REST. Every library in the scientific Python world uses it, and it means that all of our doc strings are uniformly written, uniformly structured. We have tools to parse them, to render them into into Sphinx, and it actually helps because parameters are described in a uniform way. You can extract kind of meaningful data out of them. So that's the only one thing that I would add, because the situation with doc strings in the standard library is one of those cases again of not preaching of not practicing what we preach, because basically they range from non-existent to horrible in the best of cases. But thank you very much for all of this, because you're hitting exactly all the pain points that the last 10 years of trying to do the Python in science have kind of been horrible for us.
Excellent. I think the big thing that kind of prevents people from doing that is like namespace packages in Python are a little bit of a hack, especially with like setup tools and distribute. So I think that kind of is a slight deterrent in that area, but it is definitely something that could work out pretty well, I think, to have a package like that. Yes?
I'm kind of absolute newbie to Python. I'm basically a system administrator, and I've been using bash scripts to do a lot of work. And I started to hear about Python. Everybody's using Python, and I started using it. And every time, because I use it only once in a while, and every time I have to write scripts, I have to figure out a lot of stuff. And so my question is, do you recommend I go on this path? Should I go back to writing bash scripts? Because is spending time on it and learning all these things, is it, as a system administrator, is it going to help me?
I think it can be absolutely very, very helpful. I also think, I actually really enjoy writing bash. It's kind of like this weird esoteric language that feels very rewarding when I actually accomplish something in. It makes me feel like a real hacker. It's kind of like using JavaScript or something. So I don't know. I think there's definitely like every tool has a time and a place. It's definitely applicable. I wouldn't be using Python for things that are very simple and easy to do in C. But I think if you learn Python and go down the path, I don't think it'll be that hard. Like there's different libraries that makes it really easy to like make shell out to external commands. I wrote one called Envoy, which makes it extremely simple. It's kind of like the way you do it in Bash. But that's like it's just a standard library that kind of has that main issue, which is the thing that's built in. So I think that it would be very, very valuable to learn because like it's extremely powerful compared to Bash. You can do things that you could never imagine doing in Bash, but different tools for different tasks.
Hi. So given that it's really hard for me to get my package onto PyPI without tapping someone on their shoulder, may I please tap you on your shoulder to help me get my project on PyPI, preferably sometime later today?
Yeah, absolutely. I'd love to help.
All right, thank you very much. I mean, there's something really awesome about putting you right on the spot at a point in time when you can't possibly say no.
I will. It's only for a fee, though. Cash only. Any other questions? Oh.
Just a quick one. So I have experience in C, Perl, Python, Java, and Go most recently. And has anybody yet invented a language that makes Unicode easy? I don't think it's the languages. I think it's Unicode is hard, and text is no longer easy.
Have you found the Unicode in Go to be any good, by chance?
Yeah, it's perfectly fine. I mean, well.
And it's supposed to be like one of the big innovations of Go, right? Is that Unicode supposed to be a true first-class citizen?
But you're still aware of it. You still have to know about it. It's like in Java. In Java, strings are Unicode, but that does not, you don't escape from it. It doesn't automatically make encoding and decoding work magically. You still have to be aware of that.
Yeah.
And I think Go is a little bit better than Java in that respect, but you still have to know about it. And it's the same thing in either Python 2 or Python 3. You have to be aware of it.
Yeah.
Plain text isn't
Python 3
easy
like
anymore.
forces you to be aware of it very quickly.
Plain text just isn't simple anymore.
Yeah.
End of story.
I'm personally kind of a fan of the way Python 2.7 does Unicode. I understand that it's like, I don't know, like once you understand it, it's really elegant. But I know like, I like that what they're doing in 3. I think it's more one of those changes though that's more like to be proper than to make it easy for developers. But it'll be useful in the long run. Yes.
So big thank you on the request thing. Just found that now. I'm going to start looking to use it. One question that I've suffered through that pain. One big question that I think I have for the entire Python community, and I know it's changing now, but SSL certificate validation.
Yes.
I think that's one of the most painful things
Absolutely.
that Java got right. I guess security is my background, so I would rather it fail secure than fail insecure. And Python right now, I don't think many people realize, fails insecure in every single web call you make.
Yeah.
It
No
just fails
verification
insecure.
in any way.
No verification, no nothing. So I didn't see if you're doing that inside requests right now.
I am. I've put actually a tremendous amount of work into making SSL like a built-in first-class citizen, and actually ship my own CA bundle. But it'll honor like the curl CA bundle if you specify it, and you can pass in like your own private certificates and such. And it's automatically on, and it just works like 98% of the time. It works perfectly.
All right.
You have the nuances of the OpenSSL library still, so everyone has different errors for different reasons.
Yep.
But yeah, that's a really big problem, I think,
All right.
in Python. And actually, that would be a good thing to add to my example, too, of doing SSL verification on the example. That would probably add another 1,000 lines of code.
Yeah, because that's definitely something that I pulled my hair out on many occasions. So.
Yeah, so that's kind of another goal of mine with requests is to like actually be the best practice in every way, like doing those SSL things and it like people don't even know it's doing it, which is great.
Yeah.
Because I think that's extremely important.
Perfect. Thank you.
Yeah, absolutely.
Thank you very much, Kenneth Reitz. We have a quick break, and we're going to be back in 5 minutes.
Thanks a lot, guys.
Ladies and gentlemen, if you could start to grab your seats, 2 minutes. Okay, folks, if you could grab your seats, please. Okay, so today is November 11th, and as I think many of you know, we take a couple of minutes every year on this day to remember the people who fought so that we don't have to. We take a couple of minutes to remember people like Vernon Fleming and Douglas Wilson, my nephew Zachary Cotton, people who gave what was asked so that we can read and argue and vote as we please without having to worry about a boot on the door in the middle of the night. And on behalf of people in places like Cyprus and Lebanon and the Congo and Rwanda and Afghanistan, places where the sight of a soldier with a maple leaf on his shoulder has for years meant that, that tomorrow might be better than yesterday. We're grateful for what they gave. I'll ask you to observe 2 minutes of silence in their honor.
So we are just finishing up, and we're going to get started in about 5 minutes with Beyond Password Secure Authentication with Mozilla Persona by Dan Callahan.
Okay.